Hi, this video is to show you how I repaired my BatteryTenderJunior. It's a BatteryTenderJunior made by Deltran. I have two of these, as you can see. Bought them both about 10 years ago, used them to charge motorcycle batteries, and in that time they've worked great up until about 6 months ago. And then they quit. The problem I had was that one of two things. When you plug it in, it's supposed to flash. With no battery charging, it flashes red with a slow blink. What mine would, once you plug the battery in and it starts charging, it should go solid red. When you're at 80%, it should blink, slow blink green, and then solid green once the battery is fully charged. Well, mine would, I'd plug it in and either it would not recognize the battery, even though the battery was plugged in, it would still flash red, or on one of them, it would flash a very fast red, faster than the normal pulse. So I looked on the internet and I found nothing other than people complaining that they didn't work or that Deltran wouldn't service them or whatever. And my choices were throw it away and buy another one, or tear into it and just see what I could do to fix it. So, being basically cheap and interested in how things work, I decided I'd tear into it. There's 3 screws on the bottom. I've already taken those out like that to save time in the video. Once you got that on, you pull the thing off. When you look at the inside of it, you'll see down in this corner there's an electrolytic capacitor that's mounted right here. Yours will be mounted closer to the board. I'm doing this video after the fact. I've already fixed these, but my object here is just to show you what I did. Basically, I can't guarantee you it's going to fix it. It worked for me. I hope it works for you. On the board, there's an LED there, which I know works because it blinks. There's some resistors. When they go bad, they'll be burnt or gone or whatever. There's some IC chips that no telling what's in there. No way of replacing that. A few other odds and ends. 2 things. The only part that I had a replacement for, other than the resistors, which weren't bad, was the electrolytic capacitor. And I also know that electrolytic capacitors have a habit of going bad after a number of years. They just dry out inside or whatever and they quit working. So, with nothing to lose, I decided I'm going to try changing that electrolytic capacitor. So you can, first thing is there's a little piece of cardboard that separates the power transformer and the 120 volts from the circuit board. You don't want those to get together, so that's why that's in there. Don't lose that. Pull the thing apart, and all you need to do the job is pliers, a screwdriver to take the screws off, and a soldering iron. So what you'll do is get a hold of the electrolytic capacitor. I'm grabbing the leads. You can grab the capacitor itself. You pull on the capacitor while you touch the 2 connection points on the back side, and it'll pop right off of there. What I did then was I looked at the capacitor. It was a 47 microfarad 25 volt capacitor. Well, I have a box of capacitors I had bought some time ago, and I have a 47 microfarad capacitor in there, but it's rated at only 16 volts. What I know about capacitors from experience is if you put too high a voltage on an electrolytic capacitor, it'll blow up. So, the only other 25 volt capacitor I had was a 470 microfarad, 10 times as much capacitance. Basically, the thing is a power supply. All power supplies have something to clean up the power. When you put in 120 volts, you have a sine wave signal. You want a flat DC coming out, so capacitors are used to clean up that signal. My guess was that that's what was used in this case. A 470 would clean up the signal as well or better than a 47. So again, what do I have to lose? I soldered that in. In order to solder the new one in, you don't have to add any solder. Just heat up the back side, here and insert the leads. Now I wasn't able to get the leads in as far as as originally they were. The critical thing here is on the capacitor itself you'll see a negative mark on one side and usually a stripe on one side, and that is the negative lead of the capacitor. Most capacitors, perhaps all capacitors, electrolytics, the negative lead has a shorter lead than the positive lead, so you can use that as an indicator too. But look for the negative sign on the side of the capacitor. On the board you'll see a small plus sign indicating the positive side. So they are marked as to which goes where. Pay attention when you take the old one out. So anyway, I soldered the new one in. It's a little fiddly to get the board back in there and get everything packed into the case tight, but with a little work I was able to do that. I'm not going to go through all of it now because it takes too much time, but what I'm going to do is I'm going to plug in this battery tender, and I will connect it to a battery and show you here that there it is, and right there it is charging. So it did work on mine. I hope it works on yours as well. Good luck. I would encourage you, when you put this thing together the first time, do like I'm doing, just plug it into an old battery or something. I wouldn't connect it up to your Ferrari on the first try. Make sure that that it's not putting out too much voltage or whatever. When you first do it, if you put a voltmeter on the plug, you will read 0 voltage, because what it does is it senses the voltage, and it won't put out any power until it's connected to a battery, senses a battery that needs charging, and starts charging. I hope that's helpful to you. Again, proceed at your own risk, and good luck.